The night sky has a strange way of calming us. You can sit under a vast blanket of darkness, look up at those tiny shimmering points of light, and suddenly your mind slows down. Everything feels quieter, softer, almost dreamy. But most people don't know that the peaceful glow above our heads hides stories older than Earth itself. It hides the dust of ancient stars, cosmic particles drifting across time, carrying memories of creation. And tonight, we're going to explore something very gentle but very grand. Sleepy facts about stardust. So settle in, breathe slowly, and let your imagination loosen, because these aren't just facts. These are stories about where we come from, what we're made of, and how the universe tucks us into its history. Now that your eyes are adjusted to the calm, let's begin with the first sleepy fact. And this one is important because it doesn't just change how you see the universe, changes how you see yourself. So here we go, easing into fact number 1. When we talk about stardust, we aren't being poetic or metaphorical. It's not a romantic phrase invented to sound nice in science books or space documentaries. It is literally, physically, scientifically true that almost everything around us, from the air we inhale to the bones under our skin, comes from stars that lived billions of years ago. This might sound like a simple statement, but it's one of the most humbling truths ever discovered. Imagine massive stars, far bigger than our sun, burning for millions of years. Eventually, they reach a point where their fuel runs out, their cores collapse, and they explode in a brilliant supernova. That explosion is so powerful that it forges heavy elements: carbon, nitrogen, oxygen, calcium, iron, everything essential for life. In that moment, the universe becomes a glowing factory of ingredients, scattering them across galaxies like sparks from a fire. And over enormous stretches of time so long it feels meaningless to our human scale, these particles drift, collide, gather, and spread again. They float through cosmic clouds, swirl through gravitational fields, and eventually settle into new places. Some of them ended up in the swirling disk that became our solar system. Some became part of Earth's crust. Some dissolved into oceans. Some formed the hemoglobin in your blood. Some became the shine in your eyes. So when we say you are made of stardust, we're describing a scientific process that began long before Earth even existed. You are, in the quietest and most literal sense, a tiny part of the universe remembering itself. Now, imagine this slowly, like a soft mental picture. Long before any mountain was carved, long before any ocean filled, long before any creature took its first breath, the carbon atoms inside you were already traveling through space. They had witnessed the death of stars. They had floated through the cold emptiness of interstellar dust clouds. They had ridden on shock waves, storms, and cosmic winds. They were ancient wanderers. And then, after billions of years, they ended up becoming part of a planet that would one day grow forests, build cities, develop languages, and eventually begin wondering about where everything came from. Take a moment to let that sink in. You are not just living in the universe, you are a continuation of its story. You are built from elements that once lit up the night sky as enormous suns. This is why this first sleepy fact holds such weight, because it means that every person you meet, every tree you walk past, every raindrop falling on your hand, and every grain of sand on a quiet beach shares a cosmic ancestry. It's easy to forget this when we rush through daily life, stuck in routines, stress, and noise. But the truth never changes. Even when we stop thinking about it, the core of who you are was forged in fire, older than Earth's mountains. And if you pull back and imagine the universe from a wider angle, it becomes quietly comforting. Stars are born, they live, and they die. And from their endings, new beginnings form. That cycle has been repeating for billions of years. It's still happening right now, somewhere, far beyond the edge of what you can see. A star is collapsing at this very moment, and from its final breath, new ingredients will emerge, ingredients that might someday become part of a planet or an ocean, or maybe a living creature trying to understand itself. We don't know where the dust will go next. That uncertainty is not frightening. It's peaceful in its own way. It means life is part of something bigger and beautifully continuous. Think about your heartbeat for a moment. The iron in your blood, the iron that allows your heart to pump, that carries oxygen through your body, came from a star that exploded billions of years ago. Without that ancient explosion, you would not exist in your current form. Without that star's death, your life would not be possible. So, the very rhythm keeping you alive right now is a gift from a celestial event so distant that human history feels like a flicker in comparison. And yet, here you are, breathing, thinking, wondering, listening. It's proof that the universe recycles itself with incredible creativity. This fact also changes how we think of darkness. Most people look at the night sky and see emptiness, a kind of quiet void. But in reality, even the darkest patches of sky contain tiny particles of stardust drifting silently between stars. They are too small to see. They don't glow, but they're there, floating, waiting to someday become part of something new. So when you're lying under the stars on a silent night, you're not just looking at distant lights, resharing the universe with the same ingredients that built you. And maybe the most calming part of all this is how slow everything is. Stardust doesn't rush. It doesn't hurry from place to place. It drifts. It wanders. It takes billions of years to decide where it's going next. There's something beautifully patient about that. The universe isn't in a hurry. And maybe sometimes we don't have to be either. When we feel overwhelmed, stressed, or lost, remembering this cosmic perspective can soften things. The atoms inside you have survived supernova explosions, cosmic radiation, collisions, and unimaginable journeys. You are literally built from resilience. And if the particles inside you could endure billions of years of wandering to become who you are today, maybe you can handle the challenges in front of you, too. So, the first sleepy fact, I assent. Tej assent. A fact. It's a lullaby written by the universe. A reminder that you're part of something vast, ancient, and incredibly gentle. You were shaped by stars. You carry their stories, and the calm you feel when you look at the night sky. I assent. Randomit S recognition. Somewhere deep inside, a tiny part of you remembers where it came from. Now that we've taken in the calm truth of the first fact, let's ease ourselves into the second one. And this next fact has a softness to it, like drifting through a dream, because it reminds us that stardust I assent de rare at all. In fact, it's constantly falling on Earth, even as you're listening right now. Many people imagine stardust as something far away, something unreachable or locked in space. But the truth is much gentler. Every single day quietly, invisibly tiny grains of cosmic dust drift down through our atmosphere. You might not notice them. You can't feel them landing. You don't see them shimmering as they descend, but they're there, floating through the air like the faintest snowfall imaginable. Scientists estimate that thousands of tons of cosmic dust enter Earth's atmosphere each year. It sounds unbelievable at first, because we imagine dust as something noticeable, something we could wipe off a surface. But cosmic dust is unimaginably tiny. Some motes are smaller than a strand of hair. Some are smaller than the cells in your body. Many particles burn up as they fall, glowing for a moment like the faintest shooting star before fading into nothingness. But some of them drift down gently and land on rooftops, oceans, forests, deserts, and even your skin. So, as you sit here, listening to this calm story about the universe, a microscopic piece of a comet or an ancient star could be resting somewhere nearby, blending with the dust of our world. Now picture this slowly. A tiny grain begins its journey far out in the solar system. Maybe it came from a comet's tail, one of those icy wanderers that orbit the sun in long, looping paths. As the comet gets closer to the sun, heat causes it to release small particles, like the universe exhaling. Those particles drift outward, carried by radiation and solar wind. They float for years or decades before Earth finally crosses their path. And when our planet moves through these invisible trails, the dust begins falling through our sky. Not all of it turns into bright meteors. Some simply drifts downward as the atmosphere gently slows it. There is something strangely comforting about this. Earth is not isolated or cut off from the rest of the universe. It is constantly interacting with it, breathing it in, collecting it, welcoming it. Cosmic dust settles on mountaintops, sinks into oceans, and blends with soil. Some of it becomes part of microscopic life. Some of it we swallow without ever knowing. Some of it becomes trapped in raindrops that fall onto windows at night. The division between Earth and space is not as sharp as we imagine. It's softer, like a blending of two worlds. This means that in the simplest and most literal way, the universe is always touching us, even on the quietest nights when you're lying in bed and listening to distant sounds. Tiny particles billions of years old are drifting down through the darkness, landing gently on your world. That is the second sleepy fact. Earth is never alone. It is always receiving gifts from space, carried as softly as a whisper. Now that we've floated through that idea, let's move gently into the third fact. And this one has a dreamy feeling to it, because it reveals just how delicate stardust can be. When people think of space, they imagine huge objects, planets, stars, galaxies. But stardust is almost the opposite. It's incredibly small, so small that millions of particles could fit on your fingertip. And yet, inside these tiny grains are the building blocks of worlds. Imagine holding something smaller than a grain of sugar, something you can barely see, something you might mistake for ordinary dust. And now imagine that this tiny speck has been traveling through space for millions of years, carrying complex molecules, frozen gases, or even the earliest ingredients for life. In some cosmic dust grains, scientists have discovered amino acid zima molecules that form the foundation of proteins in living organisms. That means the seeds of life itself can hitchhike through space on these microscopic particles. Think about how gentle and quiet that process is. No explosions, no noise, just tiny grains drifting through vast distances, carrying the chemistry of life like a secret tucked inside their structure. And these grains are ancient. Some are older than our sun, older than our solar system, older than anything on Earth. They formed in the atmospheres of dying stars, condensed in cooling gas clouds, or solidified in swirling nebulae, long before Earth existed. Then they floated through space for billions of years, untouched and unchanged, until they finally became trapped in meteorites or comet dust that eventually reached our planet. When researchers study these grains under powerful microscopes, they find structures so fragile that even a slight touch can damage them. Some are hollow, some are shaped like tiny crystals, some are made of layers thinner than anything we could build on purpose. They are delicate in a way that almost feels emotional, like holding memories. And this fragility creates a sense of awe, because despite being so small and so easily damaged, these grains survived journeys across the galaxy. They survived radiation, collisions, intense cold, and unimaginable time. They drifted through emptiness and still managed to carry complex molecules that may have contributed to life's beginnings on Earth. It gives you a new perspective on strength. Maybe strength is not about being big or unbreakable. Maybe it's about enduring quietly, drifting patiently, and carrying something important even when the world around you is harsh. Stardust teaches us that even the tiniest things can carry entire stories, stories older than any mountain or ocean on Earth. This leads us smoothly to the fourth sleepy fact, one that deepens the sense of connection we have with the universe. Because while stardust is ancient and fragile, it also has a way of revealing its presence in the most unexpected places. Sometimes, the dust in meteorites contains tiny diamonds, microscopic crystals that formed in the intense pressure inside dying stars. These are not diamonds meant for jewelry or decoration. They are too small to see without a microscope, but their existence is breathtaking because they show that stars can create beauty even in their final moments. Imagine a massive star collapsing, its core squeezing matter so tightly that carbon atoms bind in perfect geometric patterns. These diamonds are born in the heart of destruction, formed during the violent end of a star's life. And then, after being forged in that unimaginable pressure, they are scattered across space in the explosion. Some travel through the galaxy for billions of years. Some become trapped inside meteorites that eventually fall to Earth. And inside those meteorites, scientists find these tiny diamonds, each one a relic of a star that died long before our solar system was born. It's almost poetic. The universe hides sparkle inside stones that fall from the sky. Light born from the death of stars ends up inside rocks, resting on Earth's surface. When researchers hold these meteorites in their hands, they are holding pieces of stars' pieces that contain diamonds older than our entire planet. Think about how quiet that is. No announcement, no fanfare, no bright glow, just a small rock lying in a desert or frozen in Antarctic ice, holding secrets older than time as we understand it. And inside that rock, a diamond shaped by a star's last breath waits patiently until someone discovers it. It's strange and comforting at the same time. The universe doesn't shout its beauty, it whispers it. And if you're patient enough to listen, if you look closely, you'll find wonders hidden in the smallest places. So, as we drift from fact 1 to fact 4, the story becomes clearer. The universe is not loud or violent in its everyday expressions. It is gentle. It is slow. It is filled with small, delicate things that carry enormous meaning. Every grain of stardust is a time capsule. Every microscopic diamond is a memory. Every particle drifting through Earth's sky connects us to something older and larger than ourselves. Now that we've absorbed the quiet wonder of the first 4 facts, let's slowly drift into the 5th one. And this one feels especially calming because it reminds us that stardust doesn't just travel, it remembers. Every grain of stardust carries a chemical fingerprint, a tiny pattern that reveals where it came from. Imagine billions of grains floating through the universe, each with its own story. Like travelers who have kept journals of everywhere they've been. These grains record temperature changes, radiation levels, and the history of the space they've passed through. And all of this information becomes locked inside them, waiting for someone to look closely enough to understand. Think of it like this. A grain of stardust might form in the cooling cloud of a dying star. Then, as it drifts outward, it might be exposed to cosmic rays-eye energy particles traveling through space. These rays can alter atomic structures in tiny, precise ways, leaving traces inside the dust grain. Later, the grain might pass near a young star where warmth melts some of its icy layers. Then, it might freeze again in the cold of deep space. Over time, these changes build up. Tiny scars, tiny shifts, tiny signatures. When that grain finally reaches Earth, may be locked inside a meteorite, it brings that entire history with it. Scientists can read these histories the way someone might read rings inside a tree. Each layer of a dust grain tells part of the story, stretching back billions of years. Some grains show they traveled through interstellar shocks, places where gas clouds collided. Some reveal that they floated through regions rich in radiation. Some show evidence that they passed near newborn stars, surrounded by swirling disks of gas and dust. And it gets sleepier the closer you look. Because studying stardust is almost like meditation. Scientists use delicate instruments, microprobes, lasers, electron microscopes to examine grains smaller than a speck of powder. It's quiet work, slow work, hours spent focusing on something almost invisible. Imagine sitting in a soft, dim laboratory, listening to the hum of a machine as it measures atoms one by one, uncovering history hidden inside something so small it could float away with a breath. The calmness of this process matches the calmness of the dust itself. Stardust doesn't rush. It doesn't push. It drifts. It waits. There will no. And even after billions of years, it holds on to its story until someone gently asks it to share. That S, the heart of the 5th factive grain of stardust, is a traveler carrying memories of distant stars, distant times, and distant places. And all of those memories are wrapped inside something smaller than a single grain of sand. Now let's move gently into the 6th fact, which shows just how connected we are to the vastness of space. Because while stardust travels through the cosmos, it doesn't always remain in open space. Sometimes it becomes part of much larger structures, nebulae, the enormous cloud-like nurseries where new stars are born. It might feel strange to imagine that something so tiny could become part of something so massive. But nebulae are made of countless particles, each one drifting, merging, separating, and drifting again over millions of years. Picture a nebula, a gigantic cloud of gas and dust stretching across, like glowing softly with shades of purple, pink, blue, and gold. These clouds look almost painted, as if the universe were slowly brushing color across the darkness. And within these clouds, stardust plays a quiet but essential role. It helps cool the gas so that gravity can pull everything together. Without stardust, stars would struggle to form because gas alone resists collapse. Dust gives the gas a way to release heat, allowing small pockets to slowly condense. These pockets grow denser over time. They spin, they contract, they heat up, and eventually they ignite, forming new stars that glow with steady, comforting light. Around those newborn stars, disks of dust gather. Those disks flatten out and begin forming planets, moons, comets, asteroids, and all of those worlds inherit the stardust that was once floating freely through space. Every rocky planet you can imagine, including Earth, began as dust. Even more peaceful is the image of a nebula itself. If you could float inside one, ignoring the realism of vacuum and temperature, you would feel as if you were drifting through shimmering fog. Light would appear soft and diffused, with no harsh edges. Dust would appear as tiny sparkles when starlight passed through, each particle catching a faint glimmer before fading again. It would feel like floating in a dream, surrounded by colors that shift so slowly, you barely notice the change. And inside this dreamlike environment, stardust is the quiet architect. It doesn't announce its work. It simply gathers, cools, merges, and shapes the environment that will eventually become entire solar systems. That's the sleepiness of it. The universe builds itself patiently, grain by grain, without rushing anything. And somehow, through these slow movements of dust, new stars and planets eventually appear. Which brings us naturally to the seventh fact, one of the most gentle but meaningful ones of all. Because stardust doesn't just form stars and planets, it helps carry water across the universe. You wouldn't expect something so dry, so tiny, so mineral-based to be connected to water. But inside the icy mantles of certain dust grains, researchers have found molecules such as hydroxyl and water ice. These molecules formed when dust drifted through cold regions of space, where temperatures were low enough for gases to freeze. Imagine a tiny grain drifting alone through the darkness. A hydrogen atom bumps into its surface and sticks. Later, an oxygen atom does the same. Over time, the two bond and form a water molecule, which settles like frost on the dust grain. Then more atoms join, and more molecules, until a thin layer of ice coats the particle. This ice protects organic molecules. It cools the grain. It allows chemistry to evolve over long periods without being destroyed by radiation. And the most calming part, some of this water eventually reached Earth. When Earth was young, hot, molten, and unstable, comets and meteoroids carrying icy dust grains collided with the surface. Their water evaporated at first, mixing with gases in the early atmosphere. But as the planet cooled, water condensed, rain fell, oceans formed, and part of that water came from ancient stardust. This means that when you drink a glass of water, some molecules inside it might have been floating through space long before Earth existed. They may have traveled through nebulae, through interstellar clouds, through comet tails. They may have passed near dying stars or newborn ones. They may have been protected for millions of years inside a dust grain smaller than a speck of flour. It gives a different feeling to something as simple as holding water in your hands. The coolness you feel, the clarity, the softness of a drop sliding down your finger. It all connects back to dust that formed before the sun was born. The water inside your body, inside your cells, contains atoms that were once part of interstellar ice. And those atoms arrived here quietly, carried by gentle grains that drifted across unimaginable distances. So here we are at the end of Fact 7, with a deeper understanding of how patient, delicate, and interconnected stardust truly is. It travels with memories. It creates stars. It brings water. It drifts through time with no urgency, shaping the universe in slow, soft ways. Now that we've drifted through the soft wonder of how stardust carries water across the universe, let's ease ourselves into the 8th fact, which feels almost like a secret that the night sky whispers to anyone patient enough to listen. It's about how stardust helps create organic molecules, the very ingredients of life. And this isn't an exaggeration or a poetic metaphor. It's real chemistry happening in the quiet coldness of space, in places where temperatures fall far below anything we experience on Earth. Imagine tiny dust grains wandering through the darkest, coldest regions of the galaxy. These grains are covered with thin layers of ice water. Ice, carbon dioxide ice, methane ice, ammonia ice. When ultraviolet light from distant stars hits the ice, something magical happens. The energy rearranges atoms and bonds them together into new structures. Molecules like formaldehyde, methanol, and even amino acid precursors begin forming. These are early building blocks of life, created not in oceans or warm pools, but in the calm stillness of interstellar clouds. Picture a dust grain no larger than a fragment of powder on its surface, invisible to the naked eye. Little bits of chemistry are slowly unfolding. Hydrogen atoms drift by and settle. Carbon atoms stick in place. Nitrogen loops around and attaches. Over millions of years, the grain's icy surface becomes a miniature laboratory where molecules grow more and more complex. It happens slowly, painfully slowly, from a human perspective, but time means nothing to stardust. It simply allows the universe to sculpt life's ingredients, layer by layer. What makes it even more calming is the idea that life on Earth may have begun with help from this drifting cosmic chemistry. When comets and meteorites carrying stardust collided with the early Earth, they brought these complex molecules with them. They landed in water, mixed with minerals, reacted with heat or cold, and eventually contributed to the rich soup of chemicals that gave rise to life. So when you look up at the sky and see the Milky Way stretching across the darkness, you're not just looking at Star Zoo, re-looking at the birthplace of the molecules inside your body. Think of your eyes, your skin, your heartbeat. Every part of you contains atoms that were once floating as stardust, participating in this slow interstellar chemistry. The amino acids that make up your proteins, the carbon that forms your DNA, the calcium in your bones, all of them were shaped inside stars and assembled into early building blocks in the vast, gentle coldness of space. The universe was quietly preparing the ingredients for you long before Earth existed. This fact alone is enough to make you feel small, peaceful, and connected all at once. And now, with this gentle thought still settling in your mind, let's drift into the 9th fact, which tells us that stardust doesn't just float freely. It sometimes becomes trapped inside comets. Comets are like time capsules of the early solar system, made of frozen gases, ice, and dust grains, all preserved from the moment the planets began to form. When a comet travels toward the sun, its ice begins to vaporize, creating a glowing tail. Inside that tail, millions of grains of stardust are released into space, sparkling in sunlight for a brief moment before drifting away again. Imagine a comet as a traveler that has been wandering around the sun for billions of years, following a long, stretching path that takes it far beyond the orbits of the planets and then back again. It carries with it the oldest dust in the solar system, dust that predates the sun, dust from other stars that lived and died before our star was even born. Each time the comet swings close to the sun, it lets go of some of this dust, releasing tiny pieces of cosmic history into the space around it. If you've ever watched a meteor shower, there's a chance you've seen stardust burning up in Earth's atmosphere. Those streaks of light are caused by small fragments of comet dust entering the air at high speed. They heat up, they glow, and then they vanish all in a matter of seconds. But within that flash of light, something ancient is ending its journey. A speck of dust that once drifted near dying stars, once floated in the quiet coldness of a nebula, is finishing a voyage that lasted longer than human history. Some fragments make it all the way to the ground, preserved inside meteorites. Scientists study these pieces, cracking them open carefully, gently examining the tiny inclusions trapped inside. And what they find is astonishing. Grains with isotopic signatures that don't match the sun or planets. These grains were formed in completely different star systems. They traveled across space. They became part of a comet, and eventually, they fell to Earth, waiting silently for someone to discover them. There's something very calming in imagining this slow cosmic cycle. Stardust forms in a star. It drifts through space. It becomes part of a comet. It is released. It falls to Earth. It becomes part of our world. It becomes part of us. The slowness of it all, the patience feels almost like the universe breathing in and out over billions of years. This brings us to the 10th fact, which is especially soothing because it reminds us that stardust isn't rare at all. In fact, it's everywhere around you, and even right now, more stardust is falling onto Earth. Scientists estimate that thousands of tons of microscopic dust rain down on our planet every year. Not big pieces, not meteors, just tiny grains drifting downward, catching sunlight before disappearing into the atmosphere. If you were to stand outside on a calm night, far from city lights, and if your eyes could see microscopic particles, you would witness something beautiful, a slow, constant drizzle of cosmic dust. Not fast like rain, not loud, just a quiet, gentle settling of tiny grains drifting down through the air, taking their time, swirling in soft currents of wind, eventually resting on the ground, on water, on your skin, on leaves, on rooftops, everywhere. Most of the time, we don't notice it. The grains are too small, too light. They sink slowly, easily hidden among Earth's own dust. But they are their pieces of other star systems, older than our sun, falling softly through the darkness onto our world. Imagine one of these grains landing on the surface of a calm lake at night. It touches the water and creates the smallest ripple, a circle spreading outward in silence. That ripple fades quickly, but the dust stays, joining all the other materials that make up Earth. And even more peacefully, this fall of stardust has been happening for billions of years, long before humans existed. Long before Earth had forests or oceans as we know them. Stardust fell onto volcanic rock, onto forming seas, onto empty deserts, and over time these tiny particles helped enrich the planet with elements that helped life flourish, If you run your hand across a rock, drink a glass of water, breathe a breath of air, or touch a tree, you're interacting with materials that include ancient stardust dust that has blended into everything around you. It's in the soil. It's in the rivers. It's in plants. It's in animals. It's in the clouds. And it is constantly being renewed with fresh grains arriving from space every day. There is something deeply comforting about this idea. You're living on a planet that is continuously touched by the universe. You're breathing air that contains atoms born in distant stars. You're walking on ground enriched by dust that has traveled across light, even without noticing it. You're part of a cosmic cycle that connects you to everything. And that S, the heart of the 10th fact the universe doesn't just exist far away in the sky. It falls gently onto Earth every single day in tiny, peaceful grains of stardust that drift down like the softest, slowest snowfall imaginable. And now that the soft glow of the previous fact has settled, we drift into fact 11, which explores something most people never even think about: the music hidden inside stardust. When stars explode, the dust they release doesn't spread in silence. In space, sound doesn't travel like it does on Earth, but vibrations still exist. Those vibrations ripple through gas clouds and dust fields, creating patterns that scientists later convert into audible sound. When these star vibrations are transformed into music, they sound like long, deep, humming tones, slow, echoing, like a universe breathing in the dark. Some recordings even resemble distant whale songs, except stretched across thousands of light. The peaceful part is knowing that while your whole life feels fast and crowded, stardust travels through the universe in slow waves, drifting at a pace so calm it would take millions of years to cross a single cosmic cloud. And somewhere inside that vast quiet, the dust carries the last vibration of the star it came from, like a lullaby that never stops traveling. When astronomers point their instruments toward nebulae made of stardust, they are essentially listening to the faint memories of ancient stars, tiny tremors that have taken longer than human civilization to reach us. And that alone makes the universe feel less like a cold void and more like a gentle night with endless echoes whispering softly across eternity. So the trail of star music leads us forward to fact 12, which drifts into the glow that stardust creates when it gathers into clouds. Some places in space hold so much stardust that the clouds become softly illuminated, not by a single bright star, but by the combined light of thousands of faraway ones. These glowing clouds are called reflection nebulae, and they shimmer with the faintest blue or silver light, like moonlit water floating in space. The dust inside them scatters starlight gently, allowing the glow to spread out in a soft haze with no harsh edges, no sudden brightness, just a calm, blurred shimmer. Imagine a fog, except instead of moisture, the fog is made of ancient star fragments gently drifting through emptiness. Scientists have taken long exposure images of these nebulae, and those pictures reveal shapes that seem almost alive, curling streams of dust, drifting wings of light, soft folds of glowing mist. And the truly dreamy part is that these clouds are constantly moving, but at a pace so slow it cannot be seen by any single human lifetime. If you stood before such a cloud for your entire life, it would look exactly the same, as if the universe were holding its breath. Yet over thousands of years, the cloud reshapes itself, drifting into new forms. Knowing that stardust can glow so softly and move so patiently makes the night sky feel like a living painting, one that shifts only in the quietest rhythm imaginable. And with that tranquil glow still settling in your mind, we flow gently into Fact 13, which reveals one of the sleepiest truths about stardust. Every grain of it takes an incredibly long journey before it ever becomes part of something solid. Stardust doesn't simply float in space waiting to be used. It drifts, gathers, breaks apart, travels again, and repeats this cycle for billions of years. Some dust grains spend most of their existence wandering alone in empty space, taking thousands of years just to move a single light. Others get pulled into passing clouds, only to be released again when the cloud heats up or is pushed apart by the wind of nearby stars. The dust moves like someone half asleep, gently drifting wherever the universe nudges it. And sometimes, the dust hides inside asteroids or comets, traveling silently across orbits until a collision releases it again back into space. Each tiny grain of stardust has lived through parts of the universe older than anything we can imagine. Entire galaxies have formed and changed while the dust was still traveling. Scientists have found stardust grains inside meteorites that are older than the sun itself. Think about that for a moment. A tiny particle older than our entire solar system, older than Earth, older than every ocean and mountain and forest you've ever seen. And right now, as you sit calmly, these ancient grains are still drifting somewhere out there, moving in slow spirals through cosmic clouds, waiting for the next chapter of their endless journey. And now, with the ancient journey of drifting dust still lingering in your mind, we quietly move into Fact 14, where we discover something beautifully strange about the way stardust gathers itself. In some corners of the galaxy, dust doesn't float in a random haze. Instead, it slowly settles into long, delicate filaments, like cosmic threads stretching across space. These filaments can be dozens of light years long, yet only a few light years wide, making them look like sleepy rivers of dust drifting through the darkness. Scientists believe these threads form because dust grains gently cling to each other through static charge, building tiny chains that eventually become long floating strands. These filaments don't rush or swirl wildly. They twist very slowly, like a ribbon moving in slow motion inside a vast, silent ocean. And as they drift, small ripples form along their length, ripples so subtle that it can take centuries for them to shift even slightly. These cosmic threads are often the first step in building entire star-forming regions. Because over millions of years they gather more dust, thicken, and eventually collapse into dense knots where new stars begin to glow. It is peaceful to imagine that even the stars we see tonight began as nothing more than sleepy threads of stardust, quietly weaving themselves together in the dark. So as these filaments stretch like ancient pathways through space, we slide gently into Fact 15, where the dust becomes something even softer, the kind that forms the faint, misty halos surrounding newborn stars. When a star is born, it begins not with brightness or heat, but inside a cold, dark cocoon of dust. As the star slowly ignites and grows warmer, the dust around it begins to glow faintly, creating a hazy shell that looks like a dim lantern floating in space. These glowing halos shift in delicate ways. The outer layers shimmer as starlight leaks through gaps in the dust, while the inner layers pulse gently. As the star's energy fluctuates, the whole cocoon seems to breathe, expanding slightly as the dust warms, then settling again as it cools, a cycle so slow you would never see it happen in real time. Some halos last for millions of years, fading only when the young star becomes strong enough to push the dust away. And inside that dust, tiny minerals form, crystals of olivine, bits of carbon, fragments of ice, all swirling so gently that if you could float near them, it would look like drifting through a snow globe, frozen in slow motion. These halos are the universe's version of a nursery, where both stars and the dust around them develop gradually, peacefully, and almost silently. It's soothing to think that the cosmos creates new light, not in chaos, but in soft, patient stages cushioned by stardust. And with that gentle imagery still glowing softly, we drift onward into Fact 16, where we find out how stardust becomes the quiet traveler of the universe. Some grains of dust get pushed by starlight itself, a process called radiation pressure, where light gently nudges the dust and encourages it to drift forward. You can imagine it like sunlight pushing a feather across a room, except the feather is a tiny grain of ancient star material, and the room is a giant expanse of space. This push is incredibly soft, so soft that a dust grain might travel only a few kilometers per hour. But in the emptiness of space, even that is enough to send it drifting across unimaginable distances over millions of years. These grains wander through star systems, pass by planets, skim along the edges of comets, and sometimes fall towards suns or crash into rocks. But most of the time, they just keep floating, carried gently by the faint pressure of light. Some grains that enter our solar system drift through the sunlight and momentarily glow as they scatter the light around them, creating the soft zodiacal light we occasionally see at dawn or dusk, that pale triangular glow rising from the horizon. Most people mistake it for moonlight, but in truth, it is sunlight bouncing off ancient stardust quietly passing through our neighborhood. The next time someone sees that faint glow, they may never realize they're looking at a river of cosmic dust being pushed ever so softly by the light of our sun. And knowing that something as delicate as a dust grain can travel through the universe for ages under such gentle guidance makes the whole cosmos feel calm, patient, and deeply peaceful. And now, after imagining the gentle drift of stardust guided by sunlight, we float softly into Fact 17, which is about the quiet way stardust forms planets. You might think planets appear suddenly, fully formed, or that gravity magically pulls them into shape. But the process is calm, almost meditative, and it starts with tiny grains of stardust colliding and sticking together over unimaginable times. Picture billions of these minuscule particles drifting through a protoplanetary disk, moving so slowly you could barely sense them. Occasionally, they bump into each other, and because of static electricity or tiny sticky ices on their surfaces, they cling. One grain joins another, and then another. Slowly, they form small pebbles, then larger rocks, and eventually vast clusters that are still mostly dust. This process can take millions of years, but it is deliberate and gentle. The grains don't rush. They drift, they touch, they merge, and the universe patiently watches as something entirely new begins to take shape. And every time a new planet forms, it carries inside it the memory of every dust grain it came from, echoes of dying stars, drifting comets, and glowing nebulae. Thinking about it this way makes planet formation feel less like a violent act of physics and more like a universe creating quietly, almost like a lullaby unfolding slowly across space. As that image settles, we move gently into Fact 18, which reveals one of the most mesmerizing traits of stardust, the way it scatters light to create the calm, pale colors of distant galaxies. When we look at spiral galaxies far away, we often notice their soft pastel glows, faint blues, pinks, and whites blending as if painted with water. Much of that effect comes from stardust floating between stars, scattering light in ways that slow, soften, and diffuse it. The dust absorbs some of the harsh, direct starlight and lets only a gentle, scattered glow pass through. This gives galaxies their sleepy, ethereal aura. Imagine sitting alone in a quiet room, looking at a candle through frosted glass, and noticing how the soft glow fills the space around it without any harsh edges. That is exactly what stardust does for galaxies on a cosmic scale, and over billions of years, as stardust drifts, dies, reforms, and cycles through nebulae, it continues to paint entire galaxies in calm, muted colors. The universe doesn't need to shout, it whispers through dust. And those whispers are what we see when we gaze at the night sky through a telescope, feeling the quiet majesty of billions of drifting grains. And finally, we drift into fact 19, which carries one of the sleepiest and most humbling truths of all. Stardust is not just part of the cosmos, it is part of you. Every atom of carbon in your body, every oxygen atom you breathe, every trace of nitrogen in your cells was once part of a star, expelled as dust and drifted through space for eons. Some of these atoms formed in massive supernova explosions. Others condensed in the quiet atmospheres of aging stars. Eventually, they gathered, traveled through nebulae, became part of planets, and found their way into the cycle of life. In essence, we are composed of material older than Earth itself, drifting in slow, patient cycles that stretch across billions of years. And yet, this isn't just abstract science. It's a profound reminder of calm continuity. You are the living embodiment of countless journeys through space, composed of grains that survived unimaginable distances and times, now quietly humming inside you as you breathe and think. Every heartbeat is in rhythm with stardust that has been drifting across the universe far longer than any mountain, river, or ocean has existed. Knowing this, there's a quiet serenity in simply existing, because your existence is the continuation of a cosmic story, written in particles no bigger than a speck of sand, but older than the sun. It's a fact that slows the mind, softens thoughts, and leaves a sense of gentle awe, the kind that makes you feel at peace with the universe, part of its patient, endless drift, as we leave the gentle echo of our own cosmic origins behind. Let us drift softly into Fact 20, where stardust reveals its patient role in forming the very building blocks of planet atmospheres. Stardust carries with it tiny traces of elements such as carbon, nitrogen, and oxygen, the very same elements that eventually become the gases surrounding planets. When stardust collides and merges during planet formation, some of it becomes trapped in the growing planet. And as heat builds and volcanic activity begins, these elements slowly outgas, forming the initial layers of the atmosphere. This process is neither abrupt nor noisy. It's quiet, gradual, like watching morning fog rise from a still lake. Each grain contributes just a tiny fraction, but billions of grains together create an invisible, enveloping cocoon that eventually nurtures life. In a way, stardust is the silent midwife of atmospheres, gently seeding planets with the elements needed to sustain life without any rush or drama. And this quiet patience mirrors the way stardust travels through space for billions of years before arriving anywhere, shaping the universe with soft persistence instead of force. With that soothing thought, we drift into Fact 21, where stardust demonstrates its tender connection to the cosmos through comet tails. Comets are sometimes described as frozen time capsules, carrying dust, ice, and gas from the early solar system. But beyond their icy beauty, comet tails reveal how stardust interacts with light and solar wind in subtle, graceful ways. As a comet approaches the sun, stardust particles are nudged by the gentle pressure of sunlight, escaping from the icy nucleus to form long, trailing streams. These tails stretch for millions of kilometers, glowing faintly, but they move so slowly that the motion is imperceptible to the naked eye. If you could watch a comet from space over a year, you would see these grains drifting outward almost as if they are exhaling a quiet sigh into the void. Stardust doesn't compete or hurry. It simply flows, following the natural rhythm of radiation and gravity, creating ephemeral streams of light that hint at its long, patient journey. When humans observe these tails from Earth, what appears as a fleeting streak across the night sky is actually the culmination of billions of grains, each taking its own slow, deliberate path, a cosmic choreography invisible except in its subtle, dreamlike glow. And finally, we float into Fact 22, the sleepiest and perhaps most meditative fact of all. Stardust is constantly renewing itself in an endless cycle across the universe. Dust that drifts through space, slowly forming comets, planets, or nebulae, eventually returns to the cosmic sea in one form or another. Stars explode, ejecting fresh dust into interstellar clouds. Ancient dust merges with newer grains, creating more complex mixtures. Some grains drift into black holes, vanishing from sight only to re-emerge billions of years later as part of new star systems. Each tiny particle has its own rhythm, its own timeline, and yet all particles are interconnected, forming a quiet web that binds the universe together. Imagine watching billions of tiny, imperceptible snowflakes falling slowly over a vast, dark landscape, each carrying memories of past storms, past clouds, past skies, drifting, settling, and rising again. Stardust teaches patience because it moves on scales far beyond human comprehension, reminding us that everything evolves in its own time, and that beauty lies not in speed, but in steady, unhurried progression. When we look up at the night sky, knowing this cycle is happening above, below, and beyond, there is a calm reassurance. The universe is alive, but softly, gently, with the pace of drifting stardust. And now, as we linger in the quiet cosmos, we drift gently into Fact 23, which reveals a most serene aspect of stardust, how it participates in the creation of planets, oceans, and water. Stardust grains often carry tiny frozen molecules of water, clinging to their surfaces like frost on a window pane. As these grains are drawn into forming planets, some of that water survives the fiery, chaotic birth of a world, eventually contributing to the liquid seas that cover it. Imagine countless microscopic droplets riding on ancient grains, drifting for eons before settling gently onto a young planet. Each grain is like a tiny courier, delivering the soft gift of water, traveling billions of years through empty space before finally arriving. Over time, these grains help fill oceans, rivers, and lakes, creating the quiet, flowing bodies of water that we take for granted. And in every glass of water we drink, every wave that laps against the shore, some portion of it may contain atoms that once drifted as stardust, slowly journeying across the galaxy. It's comforting to think that every drop is connected to the patient rhythms of the universe, that the very water we rely on is part of a story older than Earth itself. From there, our minds drift softly into Fact 24, which brings the wonder of stardust into the realm of life itself. Stardust doesn't just form water or build planets. It carries carbon, nitrogen, and other essential elements that eventually become part of living organisms. In some ways, life is a direct continuation of dust's journey. Every protein, every strand of DNA, every atom in a living cell can trace its ancestry back to stardust floating through interstellar clouds. Some of these grains endured the explosive death of stars, traveled for millions of years, and became incorporated into meteors that fell to Earth. Over billions of years, these particles joined oceans, soils, and biological cycles, eventually becoming part of plants, animals, and humans. Knowing this, each breath you take, each heartbeat, is intertwined with the slow, patient voyage of cosmic dust. The universe, in its quiet way, whispers to us through these grains, reminding us of continuity, patience, and connection. Life is not separate from the cosmos. It is stardust made conscious, a calm reminder that even amidst complexity, the universe moves in soft, deliberate rhythms. And finally, we drift into Fact 25, the last of our sleepy truths about stardust, which is also one of the most peaceful to imagine. Every grain of dust is part of a story longer than time itself. Each particle has traveled across space, survived collisions, mergers, and countless cycles of death and rebirth. Some grains have been shaped inside stars that no longer exist, and others have only recently formed in distant nebulae. Together, they form an endless cosmic tapestry, a network of tiny wanderers quietly moving through galaxies, carrying the memory of every star they have touched, every cloud they have drifted through, and every planet they have kissed. And in this truth lies a gentle lesson. The universe is vast, slow, and patient, and in that slowness lies beauty. Just as stardust drifts across billions of years, we too can move through life with quiet persistence, allowing time to shape us, guiding us, and reminding us that we are part of a much larger, deeply connected story. And so, as our journey through the sleepy cosmos of stardust comes to an end, it is time to let your mind settle into the gentle rhythm of the universe. Imagine each fact we have explored as a tiny, drifting grain, some glowing softly, some moving silently, all quietly shaping the world around you. Let the images of glowing nebulae, drifting comet tails, and patient, ancient grains fill your thoughts. Let the calm of this cosmic journey seep into your senses, slowing your heartbeat, softening your thoughts, and drawing you into a peaceful rest. Remember that the stardust that formed your planet, your body, and every atom around you has traveled billions of years to reach this moment, moving patiently, quietly, gracefully, just like the universe itself. And now, as you drift towards sleep, imagine yourself surrounded by the gentle shimmer of stardust, floating through a vast, dark, silent space. Each grain a tiny lullaby from the cosmos. Let your mind relax into the vast calm, knowing that the universe is patient, eternal, and tender. Good night. Sleep well and dream among the drifting grains of stardust that have traveled across time and space to remind you of the infinite peace of the cosmos.